The topic is about Serial Peripheral Interface. SPI protocol is a synchronous communication protocol used for data transfer between microcontrollers and peripherals like sensors, displays, and memory devices. To understand in detail about the SPI protocol, we are going to understand about the introduction of SPI protocol, key characteristics of SPI protocol, and how the data will be transferred in the data frame. We are going to understand, and coming to the hardware configuration and SPI modes, the data will be transferred based upon the modes and advantages and disadvantages and common applications of SPI. Coming to the introduction here, SPI means the Serial Peripheral Interface is the high-speed protocol and primarily used for the short distance communication, and it is a full duplex protocol, and it is a synchronous communication where the data will be transferred based on the clock signal between the devices. The clock should be synced, then only the data will be transferred. Here primarily the data will be decided based upon the SPI master and the slaves. So how the relation will be formed here is, we say MOSI, MOSI, here master output, slave input. This is the line used to transmit data from master to the slave, and we have a MISO, master in, slave out. This is the line used to transmit data from the slave to the master, and we have SCK is the serial clock. This clock signal is generated by the master and is used to synchronize the data transfer. And we have CISO. This is the slave select SS0, SS1. So here this slave select or chip select, we usually say, this is the signal from the master to select the slave device. When the slave is selected, the communication will be happen between the master to the slave, and here the communication will begin. So how this SPI work? Specifically, the master will generate the clock signal to control the communication. What are the main key features of a SPI? It is a full duplex where simultaneously data transmission will be happen, and it will be received and transmission will be happened between the master and slave, and it is a high speed compared to the I2C protocol. It is better. We are going to understand what is the baud rate and what is the ranges it will be operated in going further session. And here it is a simple hardware design but requires more wire than I2C, and it supports the multi-slave using the dedicated chip select CS. So based upon the chip select, the data will be transferred. And it coming to the SPI bus architecture, as we know, the master slave communication, the main components here is the master, the device that generates the clock signal, and it will initiate the communication. So here the master, we say the microcontroller, and the slave. So the slave is the one who is going to receive the data from the master. This device that responds to the master command and transmit the data based on the clock pulse. The communication happened in a full duplex manner that can be transmitted or received simultaneously. The master and slave devices are connected via the MOSI or MISO or the clock and the slave select signals. And here the MOSI is the master of slaving, where the slave to the master communication will happen. MISO is the slave to master communication, and serial clock is the one who it will generate the clock line that will be controlled by the master. And we have the SS and CS is the one which is active low line that selects the slave device. How the mode of communication it's happened in SPI protocol, it follows the master slave architecture where the master generates the clock signal as we know and it controls the communication. The slave sends and receives the data only when the chip select is low. Data is shifted in and out simultaneously via the MOSI and MISO. And the basic SPI data transfer steps involves the master pulls CSI low to activate the slave, and master sends clock pulse to synchronize the data transfer. Master sends data on MOSI when the slave responds on MISO in a full duplex mode like simultaneous communication. After transmit, the master pulls the CSI high to deactivate the slave. So once the transmission is completed, then it will going to deactivate. Coming to the data frame, SPI frame format consists of tip select, operational command byte, and data bytes. So here for this SPI, we don't have the start and stop conditions like I2C. How it will be controlled by the master and slave. So here it will be controlled based upon the SIP select. And frame size, it can be varied 8-bit, 16-bit, 32-bit based on the application. And key characteristics of SPI protocol. As we know, it is a full duplex protocol. Data transmission will happen simultaneously. And it is a synchronous data transmission where it depends upon the clock, the data will be transferred. And coming to the master and slave architecture, it is a faster data transfer rate, typically used for short distance communication within the single TCP. And coming to the SPI modes, there are 4 modes. These are the very important modes that are available in SPI protocol. Based upon this, only the data will be decided. So we have the polarity and the phase. So here coming to the mode 0, if we talk, we have a CPOL and CPHA. Means CPOL is the clock polarity. So it will determine that clock is ideal state, and CPHA is the clock phase. It determines that data is sampled. So whenever both CPOL and CPHA is 0, 0, then in that case, the data, the whatever the data is sampled on the rising edge, means the data will supposed to send the information. And we have mode 0. Mode 0 is CPOL is 0 and CPHA is 1. Here, the sample data is at a falling edge. And next will be a mode 2. Here we'll have a CPOL 1 and CPHA 0. The clock is high when ideal condition. Here the data sample is sampled on the falling edge. And next we have a mode 3. Here we have a CPOL1 and CPHA1. Here the clock is high when ideal and data is sampled on rising edge. So these are the 4 modes that are available in SPI protocol. for transferring of the data. It depends upon the polarity and phase. And let's take one example of the SPI frame protocol. Here, usually the polarity or the phase we are going to set at the master. After setting this initialization, we are going to select the slave select or chip select to low for communication purpose. Then the clock will be generated from the master with respect to the configuration. After configuration, we are going to send the data. So we are going to send the data at on MOSI line, master output and slave input line on the falling edge of the clock, because we chosen the mode 0 means here CPOL 0 and CPHO is 0. So it is selected on the falling edge of the clock. The slave reads the data on the rising edge of the clock. Simultaneously, the slave sends data back to the master on the MOSI input and slave output line. And after that, it's going to end the transmission, saying that the master pulls the slave select or chip select line high and ending the transmission. How data transfer can happen in SPI? So the format will be slave select goes low to enable communication. It can be transferred 8, 16, and depends upon the custom length of the data. And stop condition, CS goes high to end communication. So these are some example of how the data will be transferred from master to slave 1 and master input to slave output 0. This is the example of 8-bit, how the 8-bit data will be transferred here and how it will be received to the slave from the master end. Multi-slave communication in SPI, it support multi-slave, depends upon the slave select or the chip select method. It have each dedicated pin to for communication purpose, and it follows the daisy chained SPI mode method to shift the slave select before the data transmit or after transmits of the data. So how the program is configured in the device, based upon that it can act, and it we have the dedicated pins which should be configured. And coming to the SPI pin configuration, SPI typically uses 4 main lines, that MOSI, MISO, and clock and SS. And we aware about that all the detailed 4 lines used for transferring of the data with respect to the clock and with respect to the chip select or slave select. But pins mainly used for data communication here to activate the effective communication between the master and slave. And SPI advantages here, it will be the faster compared to the I2C, because the communication can be happen simultaneously, and it is a simple hardware requirement protocol and easy to implement, and it is a multi-slave, can communicate with the multi-slaves devices. The disadvantages of this, it don't have acknowledgement. So like I2C, we have the acknowledgement, but SPI, once the data is sent, you won't get the acknowledgement. and no error detection and correction. It should be handled manually. Automatic, it cannot be possible. And here more pin configuration is required because we need the clock and slave select and other pins for communication purpose. It is a complexity. And common applications on SPI is sensors and temperatures and pressure sensors that can be configured, and the other memory devices can be configured, and displays and SD card interfaces are configured with the SPI protocol to the master. Means here these are the slaves and master is the one who are going to control the entire communication. And coming to the speed and performance, SPI supports high data rate, typically ranges from 1 megahertz to 15 megahertz, depends upon the hardware capability. And low speed mode is 1 megahertz that can be configured sensors and EEPROM. For standard mode, the display here 1 to 10 megahertz, and high speed modes is 10 to 50 megahertz. So for communication devices. And compared to the I2C and SPI protocol, so here the SPI we know that we need 4 wires, and I2C we need 2 wires, and speed is faster in SPI protocol, and I2C it is a lesser, and it is a full duplex protocol SPI. And multi-master support, no. And complexity, it's simple but uses more wires, and power consumption will be higher compared to the I2C. And applications, high-speed devices like SD card, ADC sensors are configured. So these are some comparison between the I2C and SPI protocol. To configure with respect to the code, how the program it looks. So we need to understand the initial phase of the master and communication. So the code demonstrate here the SPI communication between the master and the SPI slave. Here is the EEPROM or any sensors. So some we require, generally some of the tools it have the inbuilt libraries. So here we require the initial libraries, and we need to understand the pins. Here we chosen the pin configurations of pin 13, 12, 11 and 10, and common ground, and 5 volts to 3. So we choosing 6 pins for transferring of our data like clock, MISO and others. And here coming to the code, master sends the data, and slave reads the data, and SPI transfers the full duplex communication. So how it happens is, so the master is the one we configure with respect to the chip select, as we define hash defined pin we chosen, and we are initializing the SPI, and this is the output pin mode. And next we are going to send some data. So the sending of the data will be 0x, and we have some wait conditions. And so once if we try to send the data here, the slave will receive the data. Here if you see, like we are insulated the SPI, and we have the interrupt routine. So we are reading the data from SPI register. So here we are sending it, and here we are receiving the data. So this is the simple code how master and slave works, and how the data should be configured in the programming.